Magic X. Okay, so let's get our magic X out. Okay, and do that really fast. Okay, so I need two numbers that multiply to negative 30 and add to negative 7. What are we thinking? What's wrong? Oh, it should be positive. Look at that. So I subtract the 5 over. Apparently I had a typo at the end of the period last. Is everybody good with that? Positive 7? All right, so let's fix that. Good catch. All right, so two numbers that multiply to negative 30 and add to positive 7. What would we get? 3 and 10. Which one's got to be negative? The 3, because I want a positive 7, right? All right, then we write it out as x minus 3 times x plus 10. This is the proper way to show the work. I know there's some of us that can do it in our heads from the magic X. This is the proper way to show the work. All right, we have a property that we're going to apply. Now, what's the name of the property? Good. So x minus 3 equals 0 and x plus 10. That's all that means is split them up, set them equal to 0. Okay, how do I move the 3? Add. How do I move the 10? Good. Okay, last thing we have to do, because we were right in the middle of this problem, right? So we just did the last little bit, is once we get an answer, remember, we have to check it in the denominator, right? So I'm going to take this and I'm going to look at it in the denominator. Is it okay in the x plus 3 denominator? Does it make it equal to 0? Is it good? Yeah, that's a good answer. What about the x minus 3? Can I put 3 into the x minus 3? No. So that makes this one an extraneous solution. Okay. Let's check out the 10. So is negative 10 okay in the x plus 3? Is it okay in the x minus 3? Yep, so that's a good answer. Okay. Again, when you're doing the Otis review, when you're doing the quiz, all you would type in is the one that works. Don't type in the one that doesn't work. Okay. That you're just going to put an X through when you're showing me your work. Okay. I think there's one or two on the review that do the quadratic thing in part of the problem. Okay, let's move on to example D. We've got 2 left here, I think, right? That's it. Yeah, 2 left. Okay. What's the very first thing I am supposed to do? Factor, right? We've got to factor the denominators. I don't have a denominator here, right? Technically, my denominator is 1. Well, I'm not going to worry about that so much. Nothing there. What kind of factoring is this one right here? Good. Difference of squares. What's the square root of x squared? X. What's the square root of 9? Make 1a. Good. All right, so I'm going to write my LCD kind of off to the side. I'm going to circle what matches. What matches? How many times am I allowed to write that? Once. Good. All right, and then I'm going to underline everything that's left. I don't really need to underline the 1, do I? Because 1 is in everything, so I'm going to ignore that. X plus 3. Okay. My next step is to multiply everything by the LCD. Okay, so in this case back here, x minus 3x plus 3 makes sense. And right here it makes sense. Okay, write those two down and we'll explain the first term here. Okay, if I were to multiply by x plus 3, x minus 3, and this one here, doesn't that mean I'm going to have to FOIL those two things back together? Don't I already know what they are FOILed together? Isn't it that right there? So technically my LCD, or least common denominator, is x squared minus 9 also. It's just another name for it. So if I'm working smart on this one, and this is why we're doing this problem, I would write that one as this. Okay? They're all the same thing, right? There's different ways it looks or different names for it. Like its formal name and its nickname. Okay? All right. Nothing to cancel, distributing 1 in, right? So that would give me x squared minus 9. All right, in the second term, what cancels? Good. What are we going to do with the 7? distribute. So plus 7x plus what? 21. Good. Okay, third term across the equal sign, what cancels? Everything. I'm just left with 2. Okay, quadratic or linear? Quadratic. How do we know it's quadratic? Squared. Okay, so that means I have to get it equal to what? 0. I probably am going to combine like terms before I do the equal to 0. So let's do a line of combined like terms. So x squared plus 7x, those guys are just themselves. What's negative 9 and positive 21? What do we think? Everybody go with 12? Equals 2. All right, if this has to equal 0, how do I move this 2 to the other side? Good. So x squared plus 7x, I've got 12 minus 2 when I bring it over, gives me 10. Good. Okay. Trinomial that's a quadratic, what do I have to use? Have I had to default to quadratic formula yet? If all else failed and magic x didn't work, I would go use the quadratic formula. I'm not going to be that mean. Okay. If I am, I did something really, really wrong on a quiz. Okay. Or a review question or something. All right. 2 numbers that multiply to 10 and add to 7. 5 and 2. So I've got x plus 5 times x plus 2 equals 0. I'm going to move my work up here. All right. What property do we need to apply? Good. Okay. So I am going to do what to move the 5? Good. And what are we going to do to move the 2? Also subtract. I'll let you catch up. Okay. Let's check and make sure our answers are good. We're looking for zeros in the denominator. So if I put negative 5 in either the x plus 3 or the x minus 3, is it going to make it 0? No, so that one's a good answer, right? What about the negative 2 if I put it in the x plus 3 or the x minus 3? Is that going to be a 0? No, so that's also a good answer. So we got 2 solutions this time. So sometimes, is it possible that both of them are extraneous? We haven't seen that, but it is entirely possible that you get 2 extraneous answers. What would you write for that if you got 2 extraneous ones? Do we know? You'd write no solution. Okay, so if there's 2 extraneous answers, your answer is no solution. Okay, or 1 if it's a linear. All right, let's really quick look at example E. First thing I want you to do on your own is find your least common denominator. So everybody find your LCD. Okay. I'm seeing x minus 5 and x plus 1. Do we all agree? Okay. I want you to take a crack because you haven't done 1 completely on your own yet. Okay, since we all know now what the LCD is, I want you to try from beginning to end. There's going to be a little foiling. There might be a little factoring later. You might have 2 solutions. You might have 1 solution. I'm going to give you like 2 minutes on your own. Everybody try it. Okay? See if you can do it from beginning to end. Be about another minute on your own. I forget to do the present to class thing. Those of you that are sitting in a weird spot, you have to remind me and let me know, okay? I'm sorry. I just click off of it if you don't want it, okay? If you're doing it digital. Okay. No matter where you are at in the process, whether you finished it or not, from where you're at, look line by line with your table partner or somebody at your table and compare your work, have a discussion. Maybe your table partner can help you where you're stuck. Okay? So everybody's looking at it with their table partner right now, no matter where you're at in the process.
Why you got smart? I don't know. Get this so and then they were the same. Okay, so negative. That. And I did that. Did the
Okay, let's bring it back. We're going to talk about it together. Okay, and then we'll talk about, I made a decision while you guys are trying this problem, so I'm going to update you on what's going to go on with the quiz, okay? All right, so we're going to start canceling, right? What do I get to cancel in the first term? X minus 5. What happens with this 3? Distribute. So we have 3x plus what? 3. Good. All right, what cancels in the second one? Good. What process do I have to do there? I have to FOIL. So what's x times x? X times negative 5. 2 times x. Good. And 2 times negative 5. Good. And then we got an equal sign. All right. What cancels across the equal sign in the third term? Good. And what do I get when I distribute the 3? So I get 3x what? Plus 3. Okay. And woohoo, the fractions are gone, right? What's the next thing that I need to do? Combine like terms. So I'm going to start with my highest exponent, which was x squared. Okay. Let's see what happens here. I've got 3x, negative 5x, and positive 2x. That all cancels out, right? Because it's 2 plus 3 is 5 and negative 5, right? So that's all gone. All right. What about 3 and negative 10? Negative 7. Good. And then that equals still this 3x plus 3. All right. Linear, quadratic. Quadratic. That means I need to get it equal to what number? 0. And I would prefer to leave this leading coefficient as a positive 1, right? So I'm going to move this over and that over. So how do I move the 3x? And it doesn't have any friends, so we're going to write it down as negative 3x. What do I have to do to move the 3 over? Subtract. So negative 7 and negative 3 is? Boy, if we were playing the lottery after this lesson today, I would pick 3, 7, and 10. They've come up in almost every single problem, haven't they? All right. In some way, shape, or form. All right. 2 numbers that multiply to negative 10 and add to negative 3. Negative 5 and 2. Good. So we've got x minus 5 times x plus 2 equals 0. All right, what property do we need? Good. Zero product property. All right, so we've got x equals, how do I move the 5? Add, how do I move the 2? Good. Let you make sure you've got it all. I'm going to zoom out just a bit. Ooh, we might have an issue, huh? Okay, we always at the end check our answer into the denominator to see if it makes it 0. So if I put 5 into this denominator, does it make it 0? So that one's extraneous, okay? If I put negative 2 into this denominator, does it make it 0? What about this denominator? Does it make it 0? No, so that's a good answer, okay? All right. We don't have a ton of time. So I need to talk a little bit about how you were graded in here because we have new people and I need to refresh some memories on those of us that have been here since last semester because we